All right, all right, all right. Guess what? Last section. Okay. So this is our last section. Hopefully, we can get all of chapter 7 done. I think most of it, I'm kind of simplified some of it for you guys since we're on an online basis right now. Just realize your test is this last test is going to be on MyMathLab again. It's there. It'll open up. Your assignment should have it listed already. And then the final will be the following week. I'll get to you on the day. We'll have it open for you. I haven't gotten the final yet, but it will be on Blackboard. So make sure you can get on Blackboard for the final. Third test is still on MyMathLab. So last section is real numbers. The rest of all real numbers. We've already talked about real numbers. Everything that we've talked about this semester has been about real numbers. And there's only one other type of real number we've got to talk about. Okay, we've talked about whole numbers, natural numbers. So we went natural numbers, we added the 0, got whole numbers. So all natural numbers are inside whole numbers, right? And then after whole numbers, we went to integers, and all natural numbers and all whole numbers are in integers, but now we added negatives. And then we went to rational numbers, and rational numbers are all fractions. So all the whole numbers, all the integers are inside the rational numbers. That leaves us with one other type of real number that we're going to talk about. Okay, so let's get into that. Whoops. So the next one is every rational number can be expressed in either a terminating decimal or a repeating decimal. So terminating decimals and repeating decimals are rational. Okay, now there are some numbers that are non-terminating and non-repeating decimals. These are called irrational numbers. In other words, we cannot write them as a fraction. Cannot write them as a rational. Okay, or A over B. Okay, terminating and repeating decimals, we found out we can write a repeating decimal last section, or 2 sections ago, on into a fraction. Okay, there must be an infinite number of non-zero digits to the right. Okay, in other words, it's got to keep going. They cannot repeat at any point in time. Okay, now a lot of them, okay, are going to, well, let me go back a second. Okay, we're going to talk about most of them, but one of the characteristics you're going to have that you may know, you may not, but some of the irrational numbers we're going to talk about, most of them are going to be things that don't simplify in square roots. Okay, we're about to talk about those. But also another irrational number is pi. Because if you remember, it goes on forever, doesn't repeat. Okay, another one is e. Okay, now these are ones that you probably aren't going to do a whole lot with, but when I say e, that's the letter e, little e. Let me draw it better. Okay, and that is also a number like pi that doesn't repeat and goes on forever. Okay, but when we talk about real numbers, everything has to be real. Okay, so all right, so the big part of irrationals are going to come from the study of area, because this is where square roots come into play. Okay, so the area to calculate, you're going to have to, a side squared, and area is side squared, okay, which would be 121 for each side. Okay, but if you know the area is 49 and you take the square root of that, that means the side either has to be 7 or -7. But of course, -7 doesn't count because you can't have a length that's negative. So 7 is the only possible solution. Well, on these, when I take the square root of 49, that's a whole number. Okay, the square root of a non-negative number, a, is a number such that x squared makes it a. Okay, if a is any non-negative number, the principal square root is denoted as the square root of a. Okay, so the square roots of 144, 12 and -12. Okay, so then take the square root of that and I get 2 different answers. Okay, the principal square root of 144 is just 12. Okay, now most of the time when we find the square root of something, it's gonna be solving an equation. If I just ask you to find if I just give you the square root of 144, and then it's going to be your principal square root of just 12. Okay. What I tend to tell my algebra kiddos is if it's an equation, like x squared is equal to 144, you're going to have two possible answers. Okay, because I can put 12 there and negative 12. Okay, so when I take the square root of both sides, you get the plus or minus. But if it's just find the square root of 144, then it's the principal square root. So since it's just the square root of 4 over 9, you're just finding the principal square root of that, okay, which would be 2/3, square root at the top, square root at the bottom. Okay, now you can have other roots besides square roots. Okay, a square root is things in groups of 2. Okay, an nth root, you're looking for groups of n. So you can have a different number, and you're not. I did not do any of the nth roots on your problems. Okay, these are all other things I'm not going to get into because you're elementary ed, and you don't need to have actually take any of these to go through. Okay. So some square roots are rational like others, like square root of 2 are irrational. All right. If the square root can be simplified, square root of 36, that is rational because it's 6. The square root of 34, this is irrational. Okay, because the square root of 34 can't be simplified to a whole number. Okay, it's got to be able to simplify to other real numbers. All right, a set of real numbers R is the union of the set of rational numbers and the set of irrational. In other words, all real numbers can be based upon rationals and irrationals. The decimal form of any real number is either terminating, repeating, or non-repeating. Every integer is a rational number as well as a real number. Every rational number is a real number, but not every real number is rational. Okay? So basically, all reals break down to irrational and rationals. And then integers, whole numbers, and natural numbers are all inside the rational realm. None of these here on the right side can go into the left side. And that's a big thing that you've got to be able to understand. Now, properties of real numbers, they are closed. Okay, any real number plus another real number will give you another real number. Okay, they're commutative by addition and multiplication. They're associative. Okay, they have the identity of if you're adding of 0 and multiplying of -1, all things that we've done before. They have an inverse property. A plus the opposite of A is still going to, so a real number plus its opposite is still going to be 0. Okay. Distributive, it does work over distributive, and multiplication of real numbers still give you 0. And you can still find the other real numbers. And the last part, again, this is nothing on your homework, just as an FYI. Okay. Rational exponents can be, and radicals working hand in hand. Okay, a rational exponent is an exponent that has a fraction. Okay, and any exponent that has a fraction can be written as a radical. Okay, so again, I'm like, there's no questions on this. You don't have to worry about it. But x to the 2/3 would be the cube root of x squared. Now, how do I get to all that? Well, this here, okay? The top number is your power. Your bottom, your denominator, is your index number, which is this number here, okay? So it's something very simple, but again, you're not going to be testing on it. I left it in here for you guys, okay? And I left this here, so you can just see, we'll just kind of go through these. If I want to simplify this, think of it this way. Well, they do it this way. Change this to a power, so 2 to the 4th power to the 1/4 power, and when you multiply your exponents, you get 1, so it's just 2. Do the same thing, change the 16 to 2 to the 4th power, okay? And I wouldn't have done it this way. I would have done it, let's show you this way. If you're gonna do this, you might as well just do same way as I did the other one, to the fourth, all to the 5/4. And multiply your exponents. If you multiply your exponents, you get 20/4, or 2 to the 5th, which is 32. Okay, this one, negative. Now I can take the negative. You can do this a couple different ways. You can do the cube root of -8, which is actually -2. Or you can do -2 cubed to the 1/3. And again, you still get -2. Okay, this one, I would do 5 cubed, that's 125, to the -4/3. Multiply your exponents, that's going to give you 5 to the -4, which is going to be 1/5 to the 4th. And then you can figure out what 5 to the 4th is. 5 times 5 times 5. I think it's 625 maybe. And then this last one, I do like you did up here. Okay, so the only difference to that last one, let's get to it. Okay, you can't take a 4th root of something negative. You're going to get other things that we don't be able to do. But I will tell you this, none of this is in a homework or test or any of that fun stuff. So you're going to be fine with that. Okay, so I believe we are now done. Keep a track of your My Math Lab for your last test. It'll be next week. And you'll have your time frame. And it says all on top of it, just like your last one. All right.